Hi, welcome to this video. Just going through last year's 1 year National 5 Prelim. I'm going to do paper 1 here. What I suggest is it's going to be quite a long video because we're just going to go through the solutions to the whole paper. If there is any questions that you are in particular stuck on, I would fast forward to the video to the ones that are more relevant to you. Okay, so starting with question 1 here, you have evaluating fractions. So when you're dividing fractions, firstly you need to rewrite these as improper fractions, so 3 3/8 turns into 27 over 8, and we are dividing by 9/4. When dividing fractions, we need to keep the first fraction the same, change your divide to a times, and then flip your second fraction. So 27 over 8 times by 4/9. Now this is a non-calculator paper. You've got two options here. You can either multiply first and then simplify, or simplify and then multiply. And I think it'll be easier for you to do the latter. Okay, so anything on the top can simplify with anything on the bottom. So you've got 27 and 9 both in the 9 times table. So divide them both by 9. That will be 3 and that will be 1. Right, that'll be 1. 4 and 8 are both in the 4 times table, so divide them both by 4, it'll be 1 and 2. And then to multiply fractions, dead easy, with times the tops, times the bottoms. So 3 times 1 is 3, 2 times 1 is just 2. Okay, now your marking for this is, the first mark is for changing it to a mixed number. The second mark is timesing by the second one flipped, and your third mark is complete the calculation. Now you can only get that third mark if the answer is simplified, and it's much easier to simplify here than it is later on. So I would recommend doing it that way. Okay. So second one, the number of missed hospital appointments over a period of 21 days, where those find the lower quartile, median, and upper quartile. Now, before we start this, your numbers need to be in order. Okay, it doesn't make any sense to do it just from a random list. So they need to be in order. I'm going to pause the video and put them in order just to save you watching me do that. Okay, so there you go. There's it written out in order. Now we're looking for the median, so we're just coming in from the side to find the middle term. Right, your middle term, your median is going to be 19. Okay, so that's your median. Then you need to find the lower quartile, which is the median of your bottom half. So in the middle of that is going to be in between 15 and 16, so it's going to be 15.5. And then your upper quartile is going to be in between 23 and 25, so 24. So your lower quartile is equal to 15.5. Your median, or your second quartile, is going to be 19, and your upper quartile is going to be 24. Okay, now to calculate the semi-interquartile range, okay, the SIQR, just the same as your range back in the day was highest takeaway, lowest. Your semi-interquartile range is the range of your quartile, so the biggest quartile take away the smallest quartile, and the semi-interquartile range divides by 2. So it's 24 subtract 15.5 divided by 2. And I've just realised I made a terrible error and put the upper quartile in the wrong place. It should be in between 25 and 26, so 25.5. Okay, which changes us to 25.5. Really sorry. Okay, so 25.5 take away 15.5 is 10, divided by 2 is 5. Okay. Okay, now marks here. Firstly, after putting them in order, so that's your first mark, and then 1 mark for each of your quartiles. So I would have lost the 4th mark because I'm a tube. Okay, and here your first mark is for knowing how to calculate the semi-interquartile range, and your second mark is for going through that. So for the mistake I made, I would have lost this mark 4, but would have got both of these marks because they were right from my incorrect answer. Okay, so question 3, factorise. First thing you're looking for all the time when you factorise is a common factor. You always need to double check it's there because you're going to lose marks if you don't find it, and it also makes the factorisation easier for you. So this one here has a factor of 2. So 2 can come out the front and it's going to leave an x squared plus 5x minus 14. Okay, and then you need to look inside that bracket and see if it factorizes further. Now what you have there is a trinomial. Okay, and x multiplied by x to give you x squared. Your factors are 14, or 1 and 14, and 2 and 7. Okay, the one that screams out 5 is your 2 and 7. You know it's going to be a plus and a minus because it's multiplying to a negative number, and plus 7 take away 2 gives you that 5 in the middle. So that's your final answer there. Okay. Now your marks, very simple here. Your first mark is for taking out the common factor, and your second mark is for factorising the trinomial left in the bracket. Okay, this one here, not a very nice one, evaluating 81 to the power negative 3/4. Okay, so there's a couple of things you've got to deal with here. Firstly, you've got two things going on in that power. You have a negative power and you have a fractional power. The negative power, x to the power negative m, for instance, that really means, well, the size of the power is correct, but it's in the wrong place. It should be on the bottom of the fraction. So this 81 to the power negative 3/4 becomes 1 over 81 to the power 3/4. Now your fractional powers, anything that's in the bottom of your fraction in a power really means the power of the root. Okay, just like a flower, just like a tree, the bottom is the root. So here, because there is a 4 in the denominator of my fractional power, that really means the 4th root of 81 cubed. Okay, so that's a bit messy. Cubed. Okay, now your 4th root of 81 means what can you multiply by itself 4 times to get 81? If you're sitting in an exam, it'll be a non-calculator paper. It's always going to be something that you can figure out or guess quite easily. Okay, if it's something with a big power, like 4, it's going to be 2 or 3. Okay, so 3 times 3 is 9, times 3 is 27, times another 3 is 81. So 3 times 3 times 3 times 3 is 81. So the 4th root of 81 is 3. So that 4th root of 81 cubed becomes 1 over 3 cubed. And 3 cubed is just 3 times 3 times 3, which is 27. Okay, marks here. The first one is just for writing it as a fraction. The second one is for writing it with a root instead of a fractional power. And then the third one is for calculating what it is. Okay, so 3 marks there. 1 for the fraction, 1 for the power of the root, and then 1 for calculating what it actually is. Okay, question 5, vector components. Find the component of the resulting vector 2a minus b. So I'm doing 2 times 2, 2 minus 1, take away minus 2, 4, 0. So that 2 times that vector is 4, 4 minus 2. And then I'm subtracting negative 2, 4, 0. So 4 subtract negative 2 is 6, 4 take away 4 is 0, and negative 2 subtract 0 is negative 2. Now calculate the magnitude of this resultant vector. Remember, magnitude can also be denoted with the 2 lines at either side of your vector. So the magnitude of 2a minus b is the square root of all your components squared and added together. Just a big Pythagoras sum. Okay, non-calculator paper, so we're going to have to do this without. So that's 36, that's 0, and that's 4. So this is the square root of 40. Now we need to calculate the magnitude of this resulting vector, leaving your answer as a sub in its simplest form. So root 40, that really means root 4 times root 10. Because we're looking at our factors of 40, which are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. and you're looking for a square number. So 4 is a square number, so it becomes root 4 times root 10. The square root of 4 is just 2. Root 10 we don't know, so it's just 2 root 10. Okay. First mark up here is for setting up your sum. So knowing how to calculate with vectors, and the second one is carrying it through correctly. Your first mark down here, 1 is for setting up the magnitude. The second one's for calculating it. The third one is for splitting up into its factors. And the fourth one is for completing that process. Now, I think that's probably a little bit generous. It won't always be like that. I would give 1 mark for the last 2 steps combined, but that's the marking scheme as it stood for last year's prelim. Okay, multiplying the brackets and simplifying. Okay, we've got our rainbows. This x is going to multiply by everything. So firstly, x times x squared is x cubed. Then x multiplies by 3x, which is 3x squared. And then x multiplies by the 8, which is 8x. Then your negative 2 is going to multiply everything. So negative 2x squared. Negative 2 times 3x is negative 6x. And negative 2 times 8 is minus 16. Just be careful to multiply everything by the negative 2. Okay, then we simplify. X cubed, nothing else goes on with x cubed, so that's just going to be x cubed. We have 3x squared, take away 2x squared, so that's just an x squared. And then 8x take away 6x is minus 2x, and then your minus 16, nothing else going on with numbers, so that's your that's an end. Now, part B is an unusual question. We now have to express this multiply brackets minus x cubed in the form of x plus a all squared plus b. Now, the first thing to notice is that this bracket here, or these two brackets here, are what we've just broken, what we've just expanded up here. So instead of being x minus 2 times x squared plus 3x plus 8, we know it really means this now. Okay, so this bit here can become, well, that's x cubed plus x squared minus 2x minus 16. We're still going to have this extra minus x cubed at the end though. And that's where the trick comes, because now we've got an x cubed at the start and we're taking away x cubed later on. So they'll cancel out and leave us with x squared minus 2x minus 16. Okay, and there, then we can write it in that form, in that completing the square form. So we know the bracket is going to come from half of my minus 2. So the bracket is going to be x minus 1 all squared. Then you should be getting a factor of plus 1 coming out of there. So we're going to take away 1 to cancel that out, and then take away the 16 at the end. So this becomes x minus 1 all squared, subtract 17. Okay, again, I'll be a bit of a tube. Up here, made a wee mistake, I hope you've caught it. The plus 8x minus 6x will be a plus 2x, which is going to change down here to plus 2x and plus 1 in the bracket. Okay, now you're marking. Okay, up here, the first mark is for calculating the first 3 terms, so multiply everything by x. The second mark is doing the next 3 terms correctly, and then the third mark is for collecting them together. So that's the mark I wouldn't have got there. Okay, down here, the first mark is for substituting and then simplifying to here. The second mark is for getting the bracket correctly, and the third mark is getting your negative 17 at the end. Okay, question 7. Okay, we need to express 5 over 3 root 5 with a rational denominator. Okay, so the denominator is the bottom of a fraction. If we want it to be rational, that means we do not want any surds there. Okay, so to get rid of this surd, okay, to get rid of this root 5, best thing to do is multiply by itself, because root 5 times root 5 is just going to give you 5, because it's root 25 square rooted gives you 5. Okay, now if you multiply the bottom by root 5, you need to multiply the top by root 5 as well. Okay, so 5 times root 5, number in third, is just going to become 5 root 5. Root 5 times root 5 is just 5, times by 3 is 15. Okay, then looking at that fraction, 5 and 15 are both in the 5 times table, so we can divide them both by 5. That'll give me 1 root 5 over 3. Okay, so marking, first mark is for knowing to multiply top and bottom by root 5. The second mark is for doing that correctly, and your third mark is for simplifying. Okay, doke. 3 questions to go. Number 8, simplify. Firstly, you need to simplify the numerator. Okay, x to the power 5 multiplied by x cubed. You're adding the powers, so that's going to become x to the power 8 divided by x to the power negative 2. Then when you're dividing with the same thing with powers, you subtract the powers. So 8 subtract negative 2 is 10. So it's x to the power 10. Marking for this, you're going to get 1 mark for getting the x to the power 8 by adding your powers, and then the second mark for subtracting your powers correctly to get x to the power 10. Okay, number 9, triangle ABC has dimension as shown. Callum calculated that the exact value of cos ACB is a negative 1 over 6. Okay, is he correct? So firstly here, we're looking for the exact value of cos ACB. So to go from A to C to B, you create this angle at the top, ACB. Okay, now as a non-calculator paper, a lot of the time these questions will be in a calculator paper. The trick here is they've not asked you for the angle, they've asked you for cos of the angle. Now you have 3 sides and you're finding out something to do with an angle. Okay, you're going to be using your cosine rule, which from your formula sheet is this. Cos A is equal to B squared plus C squared minus A squared, all over 2BC. Okay, it's finding something to do with an angle and it uses all 3 sides. Okay, the only trick with this one is if you're looking for angle A, side A we know is going to be opposite the angle A. So the one opposite the thing we are working with goes at the end. So we're working with this angle, so the 13 has to go in the end there. Okay, so B squared and A squared, C squared can be 9 and 8. It doesn't matter what we round, so it's 9 squared, add 8 squared, subtract 13 squared, all over 2 times 9 times 8. Now, that's going to be cos ACB, sorry. Okay, so cos ACB is equal to that, and we have to show that this is the same as negative 1 over 6. So 9 squared is 81, 8 squared is 64, and 13 squared is 169. Okay, 2 times 9 times 8, 2 times, well, 9 times 8 is 72, times by 2 is 144. Okay, so 81 add 64, that's 145. Take away 169 is negative 24 over 144. And then we just simplify that fraction, negative 24 over 144. A couple of ways you can do it. 2 times table, 4 times table, 6 times table even, but you're actually on the 24 times table as well, so it'll give you negative 1 over 6, which is what you're looking for. Okay, so negative 1 over 6, hence Callum is correct. That's why they call him Clever Callum. Okay, now your marks here. The first mark is for knowing to use the cosine rule. Okay, so we got a mark for showing that you're known to use the cosine rule, which will come here or here, it doesn't matter. The second mark is for substituting correctly. The third mark is for calculating all those squares correctly. And then the fourth mark is for simplifying to the answer with an explanation. Okay, or with a statement. Okay, now it's a tricky question that in that your instinct is to find costs as well, but just be careful there. If it's in a non-calculator paper, they'll always have it like this here. Okay, so question 10, the graph below shows the relationship between number of hours and the athlete trains and the number of races they have won. A best fitting straight line has been drawn into athletes P and Q highlighted on it. Athlete P trains for 4 hours a week and has won 7 races. So that means that coordinate there is 4 hours, 7 races. So it's 4, 7. And athlete Q trains for 10 hours a week and won 22 races. Oh man. Okay, so 10, 22. Okay, now what we're being asked to find is the equation of the straight line AB in terms of R and H. Okay, now the straight line, you get two options. Y equals mx plus c, or y minus b is equal to mx minus a. Okay, these are your two options. Y equals mx plus c, or y minus b is equal to mx minus a. Both of these you'll have to remember. Okay, you did not get them in your formula sheet. Okay, now for these ones here, m is the gradient both times, c is the y-intercept, and a and b are just any coordinate for the second one here. Now, if you know the y-intercept, I would always use the top one. We don't here though. We don't know what that value is. So I would be using y minus b is equal to m bracket x minus a. And for that, we need to find the gradient. So the gradient formula is y2 minus y1 over x2 minus x1. Okay, for that we need 2 points, and again you don't get that in your formula sheet. We know that if this is our first coordinate, x and y of our first coordinate, and x and y of our second coordinate. So y2 is 22, y1 is 7, x2 is 10, and x1 is 6. So 22 minus 7 is 15, and 10 minus 4 is 6. They both divide by 3, so it's 5 over 2. Okay, so now we don't know the y-intercept, so I'm not going to use this one. I'm going to use this here. Okay, we know the gradient's 5/2. We know a point. I would just use p again because the numbers are a bit smaller. So y take away b, b is 7. The gradient is 5 over 2. And then x take away a, which is 4. Okay, now the last trick here is that the equation it specifically says in terms of r and h. Okay, so we don't have a y-axis here. We have an r-axis, and that should definitely be an r. Okay, we don't have a y-axis, we've got an r-axis. So instead of y, we're going to have r. And instead of x, we're going to have h. Okay, so that's your equation of the line in terms of r and h. Okay, part B. Jason has been training for 14 hours a week and reckons he should win more than 30 races. Is he correct? Well, firstly, we now have this equation. R minus 7 is equal to 5/2 h minus 4. That equation tells us, if you know the hours, it tells you how many races you should win. If it knows how many races you won, it tells you how many hours you would have been training. Okay, so we've got a thing to check here. 14 hours a week, you should win more than 30 races. Let's check it. Let's take out h and put in 14. So r minus 7 is going to be 5/2 of 14 minus 4. Okay, and then calculate this. R minus 7 is going to be 5/2. 14 minus 4 is 10. So 5/2 of 10, well, half of 10 is 5, so 5/2 of 10 is 25. And then add 7 to both sides, R is 32. So is he correct? Yes, as the 32 is bigger than the 30 races he thinks he should win. Now, looking at marking for this, for part A, I'm going to get a mark for the gradient, a mark for substituting into the equation of a line, and a mark for putting it in terms of R and H. Okay, in part B, another 3 marks. Firstly, for substituting into the equation with 14. secondly for calculating the number of races, and then the third one is for a statement. Okay, your statement is probably going to be more involved than mine, as long as it's a statement and it has justification, so that the 32 races he wins in 14 is bigger than the 30 that he thinks he should. Okay, now that's you. That's the end of the line for the paper one. Okay, apologies for the couple of mistakes that were in there. That was just me being daft, but nice to illustrate how the marks were allocated anyway. Okay, if anything else, just let us know. But thank you for